Okay, we're going to be doing inverse variation. This is very similar to direct variation. It's similar in the sense that it has an equation and they talk about variation. And the equation is a little different. Notice that before we had y equals kx and they were multiplied. Now we're dividing the x's in the denominator, okay?
Okay.
We're going to actually do a little bit of experimenting with this. I'm going to get a blank screen before we do any problems. Just a blank white one for a minute. Redo. Back to green. We'll do this problem in a minute, but I want to just show you. If we have y equals 3 over x, this is an inverse variation. K is a constant, okay? And if I was to do x and y, we put variables into the independent variable, and then we get things out of the dependent, because y depends on what we put in x. So if I'm going to put lots of things I can put in, but I'm going to put numbers that are divisible by 3, at least so we can see that. So if I'm going to put a 3 in there, that means this becomes 3, and I'll have 3 divided by 3, which is 1, okay? Now, if I get bigger, if 3 goes up, I'm going to make it bigger, like 6, okay? That means this becomes a 6, and 3 divided by 6 isn't 2. It's actually 1/2 when I reduce the fraction. So that becomes 1/2. I want you to notice what just happened. When we were doing direct variation, as these went up, these also went up in value. Okay?
These will go down.
But these ones go down, and that's what makes it inverse, meaning kind of like upside down. Okay? And so these x values go up, but the y values will go down. That's what inverse variation means. Okay? Yes. So as the 3 gets bigger to the 6, then these numbers get smaller. So these go up, and these values go down.
Okay.
Okay? All right. So let's get rid of all this. I should have done that. And we're going to do this example. Okay? And this one says, as y varies inversely as x. And I'm going to stop at that comma and just write my equation. Y equals k over x. And I made sure when I was drawing it at first that this is a lowercase k. It makes us mathematicians happy when we keep the case the same, okay? So as y varies inversely as x, whenever you hear that, I just stop and write the equation. Y is 4 and x is 3. So in the place of y, I'm going to put a 4, and I'm going to keep my k and put in a 3. Okay, now our job is to find k. And you learned how to solve equations like this. K is being divided, so how do I move it to the other side?
Yeah, the reciprocal.
You could do the reciprocal, which the reciprocal like this is 1/3, so I'd flip it, do 3. Or you can think of it just multiplying by 3 on both sides, which is the same thing as
so it'd be
12.
12.
Yes, so k is 12. So our inverse variation equation is y equals 12 over x. Oops.
Okay,
So then we look at the last part, and it says, what is y when x is 2?
So then you would divide, and it would be 6.
Yes, we put a 2 in there. So we'll have y equals 12 over 2 with y is 6. Okay? So we have to do the same thing we did with our direct variation. We have to find the value of k. And then when we found the value of k, we plug it into the equation and finish off by what the last piece is. The first bit of information right here tells us what kind of equation we had. We had an inverse variation. The next one helps us to find k. And the last part helps us to find, which is the question, when k is found, what's the dy value? Okay.
I think I like this better because it's more like what I've been doing like the reciprocal.
Yes. Yes. All right, so now we're going to use one where it has more real-life application. Time is inversely proportional to speed, so I'm going to underline that. All right, since time is inversely proportional to speed, we're going to just write the equation. Time is inversely proportional, and we're going to make an S for speed, okay? We're going to be careful not to make it a 5, okay?
I always do that.
I know. Be really careful. So we got the first little sentence. If you normally bike to a neighboring city in 3.5 hours at 10 miles an hour. So there's a comma. We're going to stop. That'll help us find k. So what goes in the place of t?
3.5 and then equals k over 10.
What are we going to do with the 10 and the 3.5?
And last time we said we were going to multiply.
Very good. So we're going to multiply 10 on both sides. That'll help cancel it out. When we multiply by 10, what does that do to the decimal?
It makes it move.
Yes. And so this instead of 3.5 is going to be?
35.
Very good. 35, and that's what K is. We have now found K, so we can come up here and write time is 35 divided by K.
And then we are going to put...
Okay, now we got this last little bit. We have the last, how fast would you ride in 2.5 hours?
So then you're going to put 2.5.
And I did something wrong over here. Just a second. This should not be a K. My bad. It should be an S.
Oh.
Okay, there we go. Where are we going to put the 2.5?
In for T.
And for T. So we're going to have 2.5 and 335 over S. Now, this comes complicated part. How are we going to get the 35 over there and the S on top?
Do the reciprocal.
Kind of. Okay, you know how we multiply? This is not a 5, by the way. That is an, be very careful, S. Okay, there we go. Do you know how we move the S up there? We'd be multiplying by S on both sides, and they would reduce, right? And so then that would mean we would have 2.5, careful, S, equals 35.
And then you could
Divide by the 3.5, excuse me,
35.
2.5, and 2.5.
Which would equal, I have no idea.
Yes, me either. And that would equal S. I want you to notice what we did. We moved this one up here, and that one down there. So we kind of just flipped it. So if we want to in the future, if you ever have an S on the bottom like this, I'm going to just back up. We can just flip these two around, and we'll have S on the top and the 35 over 2.5. This is like a legal move or a legal way to do mathematics. It's just 2 and 1 multiplying up. So then let's get our calculator out. And we concluded that S was 14, so our speed is 14, but we can't just say 14, we have to say 14 what?
In pH.
Miles per hour, very good. Very good. Okay, so we've just done direct variation. We have to remember indirect variation, I'm sorry, or inverse variation, which is those inverse and indirect can be used together. We have, that is the equation, K over X, and so we do the same procedures. We read it, we write down the equation, find K first, and then find our unknown value.
Okay.
We're done.